Why is Earth's position so coincidental? Could it be that Earth is truly unique in the entire universe? After watching this video, you may feel as if Earth was deliberately designed. We all know that Earth is the only known planet with life. First, Earth lies within the habitable zone of the solar system. At just the right distance from the Sun, if it were too close, the surface would be too hot, water would evaporate into gas, and liquid water could not exist. Take Venus as an example. Its proximity to the Sun makes it scorching hot, unsuitable for life. If too far, the surface temperature would be too cold, water would freeze, and life would struggle to emerge or survive. For instance, Mars may have once had liquid water. But because it is farther from the Sun, its lower temperatures make liquid water unsustainable for long periods. Earth, however, is at the perfect distance, maintaining moderate temperatures and allowing liquid water to exist. This is why, in the solar system, only Earth is suitable for life to be born. Furthermore, Earth's position in the galaxy is equally advantageous. It sits in the outer region of the Milky Way, far from the center where radiation and gravity are extreme. Here, the cosmic environment is relatively stable, reducing the risks from high-energy particles, supernova explosions, and other hazards. This provides a safer environment for life to emerge. In addition, Earth has its atmosphere as protection. It regulates temperature, retains heat at the surface, and shields us from harmful ultraviolet radiation and cosmic rays. It even guards against small meteoroid impacts. Speaking of impacts, Earth also has two bodyguards, Jupiter and the Moon. Jupiter, the largest planet in the solar system, is 1,300 times larger than Earth. Its immense gravity attracts many incoming celestial bodies. One of the greatest threats to Earth is large asteroid impacts. In 1994, comet Shoemaker-Levy 9, carrying 20 fragments, collided one after another with Jupiter's equator. Experts believe that if those fragments had hit Earth, another mass extinction would have occurred. If some objects managed to escape Jupiter's pull, Earth still has another shield, our Moon. Though smaller, it can block medium-sized meteoroids. Just look at the craters on the Moon's far side to see how many impacts it has taken for Earth. Earth is also rich in resources: water, oxygen, land, organic matter, and minerals. It is the only known planet with plate tectonics. In short, Earth has everything life needs. All of these coincidences combined, don't they make Earth seem extraordinary? It almost feels as if the universe granted us VIP treatment. Was all this carefully designed by a creator to give life on Earth the perfect home? In fact, when we expand our perspective to the Milky Way and beyond, the answer changes. Our galaxy alone has 100 to 400 billion stars. Among them, Earth-like planets capable of supporting life may number at least 10 million, and in the observable universe, with a diameter of 93 billion light-years, over 100 billion galaxies have been discovered. The number of stars far exceeds all the grains of sand on Earth. In truth, our Earth is just one ordinary rock among countless billions. If Earth produced human civilization, then, in theory, other alien civilizations must also exist somewhere. Our search for life has always been Earth-centered, looking for conditions suitable for humans. But this Earth-based model may be limited. The universe is vast, and life could take on unimaginable forms. Perhaps on worlds inhospitable to us, alien life exists in ways we cannot yet comprehend. So we must broaden our vision and consider more exotic environments that might foster life. Did you know? What is the largest structure in the observable universe? You might think of the Laniakea supercluster, with a diameter of 520 million light-years, where the Milky Way is just a tiny dot. But in 2013, a new discovery shattered this record. The Hercules Corona Borealis Great Wall. Compared to it, our Milky Way, only 100,000 light-years wide, is like a speck of dust. Even our solar system, just 2 light-years across, is negligible, and Earth is even smaller. This Great Wall of the universe was identified by Hungarian and American astronomers. Using data from satellites and ground-based telescopes, they mapped the distribution of gamma-ray bursts to reveal this colossal structure. The Hercules Corona Borealis Great Wall is a massive, thread-like formation made up of billions of galaxies. It spans 10 billion light years, or 10.7% of the observable universe. To imagine its scale, even if you traveled at light speed, it would take nearly 10 billion years to cross. By comparison, our fastest spacecraft, the Parker Solar Probe, reaches about 692,000 km/h, struggling even to cross 1 light year, let alone 10 billion, from Earth. Its core lies between Hercules and Corona Borealis. Its size and formation remain a mystery. Given that the universe is only 13.8 billion years old, it seems impossible for such a structure to form so quickly. This forces us to question: are our observations incomplete, or is our cosmology itself flawed? Perhaps the universe is even older than we think. And remember, the observable universe is just what we can see. The true universe may be far larger. Perhaps we may never know its full size. Isn't that astonishing? Now let's revisit a dramatic cosmic event. In July 1994, comet Shoemaker-Levy 9, once quietly orbiting between Mars and Jupiter, was torn apart into 21 fragments by Jupiter's gravity after 2 years in orbit. Those fragments slammed into Jupiter's southern hemisphere at 210,000 km/h, causing titanic explosions. The total energy released was equal to 40 trillion tons of TNT, about 2 billion Hiroshima bombs. The largest fragment alone unleashed 6 trillion tons of TNT, 800 times the world's total nuclear arsenal. It left giant scars on Jupiter's atmosphere, each crater larger than Earth itself. Although the first impacts occurred on Jupiter's far side, the Galileo spacecraft captured the events, allowing astronomers worldwide to witness this cosmic collision. Yet even this impact paled in comparison to the asteroid that wiped out the dinosaurs, which released 100 trillion tons of TNT. If Shoemaker-Levy 9 had struck Earth, humanity might not have survived. Now, let us turn to black holes. Why can they tear apart entire worlds? And where does the matter they swallow go? A black hole is not an ordinary hole. It is a region of extreme space-time curvature, formed when a massive star collapses. Its core compresses infinitely, creating a singularity. Its gravity is so strong that nothing, not even light, can escape. As a planet nears a black hole, its near side experiences stronger gravity than the far side. This tidal force stretches and rips the planet apart, pulling it into thin strands. The spaghettification effect: these fragments spiral into the accretion disk, a glowing whirlpool of matter that orbits at incredible speeds before vanishing into the singularity. We cannot see black holes directly, but their accretion disks shine brightly, revealing their presence. In 2019, the first image of a black hole was released, showing the one at the center of galaxy M87. The dark core is hidden within a glowing ring of light. But what happens to matter after entering? General relativity says it collapses at the singularity, yet some theories suggest black holes may connect to wormholes, leading to other universes. Others believe they are gateways to higher dimensions. Stephen Hawking proposed that black holes are not eternal. They slowly evaporate through Hawking radiation. Though this process is unimaginably slow, it reminds us of a profound truth: everything in the universe, even mighty black holes, will eventually come to an end.